Now, let us see Amperes Circuital Law. It is very important. Amperes Circuital Law. Okay, see, this Amperes Circuital Law is similar to a Gauss law we have studied earlier. Okay, what we see studied in Gauss law, if we have number of charges, recall it, if we have number of charges and we have to find a magnetic field, electric field at any point, what we do, we draw some Gaussian surface enclosing the charges, okay, such that it touches the point where we have to find. Okay, then what we do, use this formula into close integration of E into area, small area which we have to find, is equal to charge enclosed in this Gaussian loop, Gaussian surface by epsilon naught. Similarly, the Ampere circuital law, it tells that if suppose we are having number of charges, we have number of current like this, one going here I1, one going upward I2, one going downward I2, I3, going upward I4, one going downward I5, like this. We draw it like this. If it is coming outward using vector, we can draw like this dot. For dot, here for dot, for this we can draw like cross. So suppose we are having one current I1 coming outward, one current I2 going coming outward, one current I3, one current I4, one current I5. We have number of current like this. One current is I6. We have number of current. Suppose we have to find a we have to find a magnetic field at this point. What is it tells? It tells that Ampere told that draw here we have draw Gaussian surface. Ampere told that draw a Amperian loop. We told draw one loop, closed loop, and he named that loop as Amperian loop. Amperian loop. We told that if you will do closed integration of magnetic field, you will do closed integration of magnetic field into dl, it will be equal to mu naught into, see here, q naught, see here, constant epsilon naught, here constant is mu naught, and it is multiplied with 1 by epsilon naught is multiplied with q enclosed, here it is mu naught into I enclosed, like this. We can write like this, I enclosed or mu naught I net. What it will be? See, how we will put mu naught I net means, see, the direction of loop. We have assumed, suppose we are assuming the direction of loop like this. We are assuming direction of loop like this. It is our will where we should assume. If we are assuming the direction of loop like this, then what will happen? You will see that if we will curl our forefinger in this direction, in the loop direction, we will see that our thumb will point downward. That means the cross current will be taken as positive. So we will write like this, I3 plus I6 positive, and rest current minus I1, minus I2, and minus I4. From where we have decided this? From the direction of magnetic field, we curl our four fingers, and the direction of thumb gives the direction of current which we have to take as positive. So for here, we will get our thumb inward direction. So inward current will be taken as positive, and this will be taken as negative. This is called as Amperes Circuital Law, and we have written definition also. That is, it is line integration of magnetic field. It is a line integration. It was a surface integration. Because we have taken Gaussian surface, it is an Amperian loop. So it is line integration of net magnetic field over a plane in a closed loop is equal to mu naught times, see here, mu naught times the net current passing through the loop. Okay, that only which we have written mathematical form, written language. Okay, Any problem getting or confused here? Any problem? Anyone? Any problem? Anyone? Any problem in Ampere's loop? Okay. Okay. Let us take some example. You will find it. You will get clear. Suppose we are having some current like this. I1, one current is I2, one current is I3. We have taken one Amperian loop like this. We have taken one Amperian loop. So that current flows like this, goes here and comes like this. This is Amperian loop. Okay, we have to find what will be the magnetic field. What you will write? Ampere loop, closed integration of B into dl is equal to mu naught into net current. See here, in this direction curl your four fingers. In the direction of loop, you will see that if you curl your four fingers, you will see that your thumb is pointing inward. That means this I1 will be negative. Okay, I1 will be negative. See, in this loop, if you will curl your forefinger in this direction, your thumb will point outward. That means I2 will be positive. You will write here I2 positive, and the current third I3 will be negative. You can put like this, you will get your answer. Getting confused or understanding? Please tell, getting confused? I3 again, sir. Okay, I tell you. What I told, see here. Once you decided the direction of loop, either it is given in question or you have decided by your own. Once you get the direction of current loop, curl your four fingers in the direction of loop. Then if you will curl your four fingers in this direction, you will see that your thumb is pointing upward. Thumb will point upward. If thumb is pointing upward, that means upward current will taken as positive. So I2 will be positive and this I3 is inward. So this I3 is inward the loop. So we will take it as negative C here. Okay. Tell, any problem? This is the Amperian loop we came to know here. Okay, you have to write the Ampere's law. Try your own. All of you try your own. If you get your answer, you please tell me. Try your own, all of you. Any answer? Any answer? See, if you will see this loop, you curl your forefinger in this direction, what you are getting? See, if you will curl your forefinger in this direction, you will see your thumb is pointing inward. So inward will be positive, but here current is outward. You will write it like this, minus I1. See here, your loop is in this direction. See here, loop is in this direction. See, curl your forefingers along this direction. The thumb will point outward. That means outward will be positive, plus I3 positive and I2 negative. See here, for this, curl your forefinger in this direction. In this direction, curl your forefingers. You will see that thumb is pointing inward. But current is I4 here dot. So we'll take it as negative. For this, we are having this one. You will curl your forefinger, you will find that it should be dot positive. So it is cross. So we write it as like this, I5 negative. Any problem in writing this? Anyone, any problem? Because it is important. Okay.